Okay, so the homework question is to find the electric field at the point P shown. Find the force on a proton placed at this point and the initial acceleration of the proton. So let's see how we'll start this. To find the electric field, the first thing we should do is draw the two electric field vectors. So here's charge 1, it's negative, so the electric field due to charge 1 goes in towards it. Here's our E1. Charge 2 is over here, electric field goes in towards the negative, it's further away so that electric field will be smaller. There's E2. So we've drawn our two vectors. The next thing we should do is find the magnitudes of these two vectors. The magnitude of electric field 1 is E1 equals K times Q1, the magnitude of the charge because we're finding the magnitude of the field, divided by R1 squared. R1 is the distance from the charge to the point equals 0.5 millimeters. Put our numbers in, 8.99 times 10 to the 9. Magnitude of the charge is 1 nanocoulomb, 1 times 10 to the minus 9 coulombs. Divided by R1 squared is 0.5 millimeters. Convert that to meters, and don't forget to square it. So we'll do that in our calculator. And we get 3.596 times 10 to the 7 newtons per coulomb. So this does point in the x direction. It points left, so the x component of vector E1 is minus 3.596 times 10 to the 7 newtons per coulomb. Now we'll do E2 the same way. E2 is K times the magnitude Q2 over R2 squared equals 8.99 times 10 to the 9 times Q2, which is also 1 nanocoulomb, the magnitude, divided by R2 is from the point to our charge. So here's R2. This is 1 millimeter, this is 0.5 millimeters, so this distance is 1.5 millimeters. And we square our R. So we'll do that guy on the calculator. And we get 3.996 times 10 to the 6 newtons per coulomb. So E1 points to the right, it would be positive. E2 points to the right, so E2x is plus 3.996 times 10 to the 6 newtons per coulomb. Our total electric field will be the net electric field, so these guys added up. So E equals minus 3.596 times 10 to the 7 plus 3.996 times 10 to the 6 newtons per coulomb. So E equals minus 3.196 times 10 to the 7 newtons per coulomb I hat. And we put it in vector notation because it's a vector. Find the force on a proton placed at this point. So to find the force, we know that force equals Q times E. Force on a proton is the fundamental charge, positive, E times E, equals 1.6 times 10 to the minus 19 coulombs times minus 3.196 times 10 to the 7 newtons per coulomb I hat. So we'll multiply this out. And we get for our force minus 5.11 times 10 to the minus 12 newtons in the x direction. So the electric field points left, so the force points left because it's a positive particle. What would be the acceleration? We know F equals ma, so A equals F over m. So we'll put in the force, minus 5.11 times 10 to the minus 12 newtons I hat, divided by the mass of a proton, 1.67 times 10 to the minus 27 kilograms. And we get minus 3.06 times 10 to the 15 meters per second squared. And that's in the x direction towards the left. So there's what happens if we have a proton. The next question asks what would change if the proton were replaced with an electron. So if we put an electron at point P, the electric field doesn't change because it depends on the source charges only. So for this part of the question, we replace the proton by an electron. So part A, E is unchanged. Then the next part, what would be the force if we put our electron right here at point P? So force equals Q times E equals minus E times E. So we'll get the same magnitude of force because E is the same, but it'll be in the opposite direction. So then the force we get would be plus 5.11 times 10 to the minus 12 newtons. For the proton it was negative, it pointed left. For the electron it's positive, it points right. So positive with I hat. And then the acceleration, the mass is different, so we figure the acceleration will be different. Acceleration is force over mass. So 5.11 times 10 to the minus 12 newtons, I hat, divided by the mass of an electron, 9.11 times 10 to the minus 31 kilograms, gives us an acceleration of 5.61 times 10 to the 18 meters per second squared I hat. So that's what happens at point P if we have an electron or a proton there.